So good morning, everybody, and welcome to our webinar about permanent monitoring of compressed air systems. Let's get started. My name is Pascal van Putten. I'm the CEO of VPInstruments, and I will start now with the presentation about permanent monitoring of compressed air systems and how they can help you to maximize your energy savings. So you probably all did come home after a nice vacation. Sometimes you found out that you left the tap water open, or something was leaking. How did it make you feel? Well, for me, that is always a reason to be a little sad, because I wasted a lot of water and wasted a lot of energy. That's also the reason why I founded VPInstruments. We want to help you with easy insight into energy flows to help you in manufacturing plants worldwide to save energy in compressed air and in other utilities. We're located in Holland, and I live in Delft, and I have 3 daughters. And this is actually a picture of my oldest daughter that was helping my middle daughter with eating her meal. And why do I show this picture? Well, as you can see, they're wasting quite a lot of food. But the great thing about children, at least my children, is that they also get better at eating things over time. And also other people give them while eating their meal. So you praise them when they're doing well, and you might give them a hug. And so eventually babies learn how to eat without waste, and the problem is solved. Well, this principle of learning and getting feedback and eventually improving is quite similar actually to energy management of compressed air systems, or energy management in general. So why is this so important? It's not only because of the money, it's not only because of compliance with energy directives, but it's also for a future. We owe to future generations to save as much energy as we can and to make our plants more efficient. By optimizing compressed air systems, we can save. Nearly 5% of the global electricity consumption is now being used for compressed air. So it's a huge savings potential. It equals almost 55 600 megawatt coal-fired power plants. So it's a lot. So typical forms of compressed air waste you will find, and this is also the savings potential, of course, are leaks, artificial demand, inappropriate use, and the other half is being used in production. So, for example, if you would have a 500 kW compressed air system, that means you would probably spend about $300,000 on electricity costs, depending, of course, on the rate that you pay for your electricity, and you might waste around $100,000 a year on that electricity just because of the leaks. And if you would invest a part of that money in a monitoring system, you can have quite a fast return on investment, because you will probably find big leaks and big wastes of compressed air a couple of weeks, maybe months after you have installed this monitoring system. Another example of that, so how we calculate return on investment. Basically, this is an example of a 3-compressor system. So if you know the running hours, if you know the rated power, you can calculate how much kWh they consume per year. And you can translate it into euros or dollars. For the sake of this example, well, there are euros in this example, but it doesn't really matter. So if you look at the total amount and you take very conservative 10%, you would spend around 7.5K in a monitoring system or in a couple of flow sensors, a couple of kW meters to check what is actually going on. That amount can be gained again in savings quite rapidly. And from that on, you could start with the next measure to invest more into energy savings. This is a real example of a steel plant in California, California Steel Industries, where we installed a monitoring system at the time together with a company, Air Power USA in the USA. We installed the monitoring system, and the people of Air Power USA, they did a great job in fixing leaks and also training the people there on how to improve basically the insulation. So an example, they had a lot of blower air, they had a lot of compressed air basically to use for cooling of ovens, and they made pipes with holes to cool down things, and those were changed into blower air, lower pressure, and with venturi nozzles they were able to reduce the compressed air consumption considerably. They also shut off old sections where the factory was not in use anymore, but there were still pipes running to those sections. So the return on investment in this case was less than half a year. And in terms of money, it was in excess of $300,000 a year savings, which are monitored by the VP Vision monitoring system permanently. And why permanent monitoring? If you do a one-time audit, you can reduce the energy consumption, take a few measures here and there, and you'll probably be able to save short term. But eventually, the energy consumption will go up, and the efficiency will go down. If you don't monitor it, you cannot manage it. So with permanent monitoring, you can keep a very close eye on the behavior of the system and always react on time instead of too late when you have already wasted a lot of money. So that's why we are a strong believer of permanent monitoring. It will keep your efficiency basically on the best possible level. It will keep your leakage level at the lowest possible level. And there are other reasons as well. Permanent monitoring will save you time because the system will do a lot of work for you. So you don't have to run around all the time. No, you will get an alarm or an alert message when something goes out of whack. And you also know where to look for. If you have a large plant, it's virtually impossible to walk or bike or drive around all those different buildings to start to look for leaks. But if you know that building A or building B has a larger consumption profile on Monday morning, then you know, hey, there is something going on here. Let's spend my time on that building and not on the other buildings. And again, it helps you to stay on top of your savings. It's basically you have extra eyes, extra ears in your factory that can help you to stay on top. Other reasons to install permanent monitoring solutions. You can also learn about your factory baseline. So what is normal for this factory? What is normal for this type of machine? And then if you want to expand the factory, if you want to invest, for example, in a new compressor, thanks to the fact that you have this baseline, you can make much better decisions in terms of investing in new equipment or selecting the right compressor. That's another reason also, sizing of equipment. So if you know that one machine is consuming this amount of CFM and you want to invest in another machine, in that case, you know it will probably double the consumption, for example. And you can also look at the capacity of your compressor and say, hey, well, we are still good. We still have enough capacity installed, or we need probably another compressor. So it helps you to size the equipment. Also, if you have permanent monitoring system separate from control, you can use it also to monitor and optimize the control system, or even invest in a different control system at some point without losing all your data, because it's a separate solution, separate of the control. And it might detect some issues which the control system doesn't see or doesn't report. Maintenance management and optimization, I already talked about that. With the monitoring solution, you know where to look for the problems. You know where to go for the biggest leak. Multi-site benchmarking is another thing. If you are part of a larger group of similar factories, you can compare your factory output to another factory output and the amount of energy which is used. So you can actually see who is the most efficient plant of the group, and you can learn from each other. Like, hey, why is this factory doing better than my factory? I'm making the same bottle of beer, so it should be the same, right? So that's another reason to have monitoring in place. Cost allocation. If you know the amount of air that goes into, for example, a piece of toilet paper or into a bottle of wine or into an aluminum can, you can allocate those costs. And some manufacturing plants might make similar products for different brands, so they can allocate costs to the different batches they make for different brands. Compliance is another thing. Compliance with local energy directives, reporting for local incentive programs from the utilities, ISO 50001, or the European Energy Directive. For compliance reasons, you need to have a monitoring system to report, to generate the data that your local government might need for the administration. And a new trend is the trend towards big data. So data collection, if you have data available, you are prepared for the near future. So how does an energy monitoring system look? Typically, in our case, VP Vision, it has a central logger, we call it the VP Vision M, which stores all the data. And it's connected through Ethernet, which makes it quite easy to also do very large projects because it's standardized infrastructure. Then on that Ethernet connection, there could be analog sensors through a converter. There could be flow meters like the Flowscope M with a direct Ethernet output. Or there could be Modbus-based flow meters also through a converter. And that's all nicely tied together on the network. And the central VP Vision monitoring software stores all that data in a database and then visualizes it in different graphs. You can see KPIs, you can see trends, alarms, etc. So where can you measure actually in your factory? Well, There are many places, of course, you could put sensors. We define two main areas. That is the demand side, where the air is consumed, and the supply side, where the air is produced. So let's take a look at the supply side. What can you do there? If you want to monitor compressor performance, you could install amp meters or kW meters for each compressor. Then you could also add a flow meter at the discharge pipe, especially if you have a large turbo compressor, centrifugal compressor. That can be interesting because then you can see the ratio between output and input. And if something happens to the compressor, like a polluted inlet filter, output flow changes and the ratio between output flow and consumed power will change. And that might be a trigger to clean the filter. A pressure sensor to see the overall pressure, but also to find pressure drops over the air treatment. Temperature sensor can also be very interesting because you can find issues with the compressor cooling system itself. You can find also issues with desiccant dryers, refrigerant dryers as well, if you look at the temperature difference between input and output of the dryer. Ambient pressure is also a good thing to log, especially if you have, again, centrifugal machines. Different ambient pressure will result in different performance. That doesn't mean that the compressor is bad, it might be just the weather. Now, going to demand side, you could install flow meters for each department to see flow and pressure and temperature. And then, of course, flow and pressure is very interesting because then you can see pressure losses. There's a large consumer consuming too much air and the line is too small, then the pressure might drop and it might cause an issue at some machine. And it might even cause a production stop. We have seen cases that give serious problems when, for example, a truck is loaded using compressed air or unloaded actually with compressed air, and then it causes an issue behind the wall at some production machine because the pressure is completely going down. And then dew point. If you have a critical application, you might want to monitor also the dew point, local application. So you don't have to waste, for example, your product. We had an example of a factory that produces things based on flour. If you would have too much water in the pipes which transport the flour in this case was transported with air, then you might get fungus inside your product, which you don't want. Now, it's all nice to have this equipment installed, but there are also some challenges. And the first one I want to address is people. Because in the end, it's all about habits and it's all about behavior change. If you look at people at the production floor, for example, or at the maintenance department, there could be lack of interest. There could be lack of engagement or maybe other priorities because production goes first. So who cares about energy consumption? We need to get out these products on time by Friday, 2 o'clock. Also lack of experience, like, well, air is free. A lot of people, used to think, I hope not anymore, but still a lot of people might not realize what's behind that door in the compressor room generating that air while they're brushing off their table every lunch break or every shift change that they want to clean it up for their next colleague. Yeah, so it's sometimes not easy. Then you start with monitoring all these nice figures, but then after a couple of weeks or a couple of months, people say, well, let's get on with production. Yeah, we don't have time for this. And there are ways for fixing things, make them the energy saver hero of the month, for example. Other challenges could be financial. I attended another conference where there was a lot of discussion about the fact that there might be conflicting incentives or objectives between the buyer that wants to have the cheapest machine and then the energy manager who wants to save energy, which might require a higher investment, but it comes from a different budget. They might be rewarded also in a different way. And then there's the maintenance manager that wants to lower the maintenance costs from long term. So sometimes you need to put all those people together in a room and really explain, like, this is going to be helpful. Like, why would I invest in an energy management system? The buyer might think. Well, the energy manager would say, well, we will save energy on long term, and for the maintenance manager, it will mean that we can lower those maintenance costs or save time. So, and one thing I think is a great solution is also to connect in a way the maintenance budget to the energy savings realized. So in that way, your maintenance department becomes basically a money maker and a sort of investment vehicle. You will invest just a percentage of the energy savings back into the maintenance, and if you do it well, things might start to amplify itself, and you might get a nice way of stacking up all those savings. Another challenge is technical. We're often dealing with old compressed air systems where the air quality is poor when you start. There could be installation challenges like short pipe runs because the system was never designed, to put in a flow meter or to put in a sensor. So now what? So if you have this too short pipe run, you could do two things. That's don't measure at all or stick in a sensor and at least get a profile and do a relative measurement. Electrical signals, there might be no data infrastructure or it might be very hard to reach the sensor. So in that case, first you have to fix that. You could maybe go wireless at some point. And sometimes you have to install an Ethernet network first or a Modbus network. And there are also many ways to do this. So many tools available. So how to make the right choice? How many sensors do you need to start? Do you need 1 or 10 or 20, or do you want to have a sensor on each machine? I'm a great believer in gradual approach. I will come back to that later. Do it step by step. Another example is what you can realize with energy monitoring is this glass factory. We do a lot of glass factories, and most glass factories have large compressed air systems. Typically, the installed compressors will probably cost you like 1.5 to 2 million a year. And those factories are often quite old, so there's a lot of savings opportunity there. And this is just an example where, similar to the steel factory I showed before, the compressed air was used for cooling. So changed compressed air cooling to blower-based cooling for the oven. Also in this case, they had some turbo machines, centrifugal machines, which sometimes had clogged inlet filters because of the environment. And by placing flow meters at each compressor, each centrifugal machine, they were able to track that and to see when the compressor would perform less, and then they would simply change the filter on time. So in this way, they were able to optimize the maintenance schedule. And the return on investment on the initial monitoring solution was less than a year. And total amount was also quite interesting. So in excess of a couple of €100,000 a year. So how to start with monitoring? I will lead you to a step-by-step plan. So this is the first step. Define your goals and define your critical performance or your key performance indicators. This is an example of typical key performance indicators you could use. One is efficiency, so the airflow at the main header divided by the total power consumption of all compressors. That gives you a good baseline of how good or how bad is your system in the beginning, and if you do a good job, then you will see that the efficiency will get better over time. Then the leakage rate, how much leakage flow is in my factory, for example, during lunch breaks, during the change of the day shift to the night shift, or maybe in the weekend. And take that number and divide it by the average flow during production. So you get a percentage of how much is leaking, or you can convert it to money, how much dollar this is on an annual or on a weekly basis. And then the cost per X, so how much air is being consumed to produce, for example, a bottle, or to produce a kitchen, or a piece of furniture or a car. This is also a great performance indicator if you have multiple sites that you want to compare. In this case, you can really allocate the energy costs for compressed air related to the widgets you are producing. So after that, you set your goals. You can start with performing an initial audit, basically to identify the current state of your factory. So typically you would install kW meters to find out how much compressors are using, but also which compressor is running at what period of time. And you want to check and monitor the compressed air consumption of your plant, so the total air consumption. And also the pressure and also the temperature. So typically there will be one flow meter, the main header, measuring what the amount is that goes into your factory. Then another sensor to add is a pressure sensor to measure downstream pressure somewhere on the production floor. And that will give you an indication of any pressure issues, for example, due to an undersized pipe network. And if there is a suspicious area where there are a lot of complaints, pressure is too low, or we have issues that the machine is stopping at some point, etc., you might want to add a flow meter or a pressure sensor at that point as well to find out what the issue is, when it happens, and how bad it is, and maybe you can solve it quite easily. What I always recommend is to install the equipment in a way that you can leave it in place, because it is the first step towards a permanent monitoring system. So if you choose the right locations, if you've done the installation work, it's only a small barrier then to leave it there after the audit. Now, after a couple of weeks, or maybe 1 week, depending on what the production schedule is, you'll have data which you can analyze together with an energy consultant or with your colleagues. And then you can make your top 3 of main issues, like, hey, we found some period of time this machine is consuming a huge amount of air, or in the weekend we found that there is air consumed while there should not be air consumed, or hey, a compressor is basically turning on and off, but it never goes into load. So why is this compressor anyway doing this? So you can find the top 3. You can also, because you have the kW consumption and you have the output flow, you can already guess or estimate pretty accurately the savings potential if you would fix that issue. And if you know what parts to order, like a new gasket or worst case, another compressor, but you can calculate the return on investment. So based on your kW consumption and an estimation of the amount of energy you're going to save. So it's a way to really have a good, well-funded approach for the next steps. And also, you can discuss how to maintain those savings afterwards. Do we need additional monitoring? For example, we had a case where during an audit, there were issues revealed with a back filter house. And in the end, the decision was we have to put a permanent flow meter in that situation because this will happen again. And in that case, the decision was made to put a monitoring flow sensor and some other equipment for that particular piece of equipment. The next step is to install a permanent monitoring system, because those sensors have been equipped with a local data logger, but now you can take the next step and install the permanent monitoring system, which can be VP Vision. Basically, this VP Vision software will enable you to keep track of the critical performance indicators. It will also alarm when things go out of bounds, and it will display all the data in a very easy, understandable way. So it can become available, for example, on a large screen in the maintenance department. The reports can be sent automatically to financial department or to an energy manager. Yeah, the monitoring system becomes really a tool for all those people involved to help them to establish the energy savings. And after a while, you might want to expand to other areas because you have then some more facts, you have some more reporting, you also have some more proof of the return on investment. So you might want to expand it to, for example, production machines, or maybe not, depending on what you find during the monitoring. Now I'm going to talk about some future trends, which we see happening right now. We see that more and more factories invest in a permanent monitoring system. I personally really believe that permanent monitoring will be standard, and maybe in some countries, and I've seen it already in some states, flow meters or permanent monitoring might become the law that you have to monitor typical equipment that uses a lot of energy. And if you don't do it, or if you waste energy, it might become a crime at some point. Maybe just a joke, but well, we never know. Also, big data and advanced analysis is rapidly evolving. So the more data collected, you all know the nice buzzwords like Industry 4.0. But by the development of this kind of artificial intelligence and advanced analysis, the role might change of the traditional energy manager or auditor, because some things can be automated, like detecting certain issues with compressors or detecting very simple pressure loss. It's a pretty simple one. And sensors by themselves also become smarter and more integrated, so there will be more functions in one sensor. Good example is, of course, our own product, the flow scope, where you have 3 sensors in one, and also direction sensitivity, so you can measure also reverse flow. And then there is a trend towards cloud-based solutions and for monitoring, but I've also seen already things that can control through the cloud. So that might sound very scary, but well, at some point it might be reality that things are controlled by something which is running in a very secure cloud environment. And I want to give you an example of deep learning and artificial intelligence, which is already reality in some other fields, like the medical field. Everybody probably can find out pretty easily on this picture who's the male or the female figure. I don't have to explain that probably. But now let's take a look at the brains of those 2 persons, and would you be able to deduct from the brain waves who is the male or the female? And the answer is yes, you can. If you monitor basically a bunch of brainwaves, in real terms it's called a EEG, and you would process that by an artificial intelligence kind of program, apply deep learning algorithms to it, the computer can tell you this is a male And this is a female with about 80% accuracy, by the way. So there's still some doubt, but it's pretty good. Now, if you apply the same thing to compressors or to energy management or to pumps or fans or whatever, and combine those data and then take a very experienced auditor that can tell, okay, if you see this and this together, then it is probably this problem. And if you teach the system well, it might take over the role of that auditor or that expert, and it will tell you there's maintenance required, or alarm X, or machine might be okay. And I've seen it already in practice during some of my visits recently in the US, where manufacturing plant had vibration monitoring software running. It was actually doing this. So that monitoring software was able to predict when the fan, in this case, would fail. So it's interesting. Just to wrap it up, cloud-based monitoring enables you to get more scalable and more flexible solutions. And it opens the door to more predictive maintenance-based algorithms. Also, it might go into a direction for some cases that you will have control of equipment through the cloud. But in all those cases, data is key asset, and you can already start today with collecting those data using our monitoring solution, which is not cloud-based, but it stores the data securely in a database, which you can connect to an external cloud service if you would like to do that. So to conclude this part, why permanent monitoring? Because it helps you to get to know your factory baseline, sometimes call it a factory fingerprint. It's also key to continuous energy savings. But be aware, it's all about people and it's all about behavior change. And it's important to have everybody involved when implementing these kind of solutions. And set the right KPIs, set the right management policy, and take it step by step. You can fund the next step from the initial savings. In that way, you can gradually grow till it's enough, to maintain your savings. And start now, because data is the key to your future energy savings. If you don't measure it, you cannot manage it. So invest in an efficient plant and a better future. Thank you again for watching. Stay tuned on our website and have a nice day.